Hey everybody, John Harper here, founder of Hackers Teaching Hackers, coming at you with Haystack Solve. So this was definitely one of the more requested solves that I've had over the years. And we typically I'll do a Haystack challenge every year. And I haven't really wanted to do a solve video for it because once you kind of know the initial solve, it kind of ruins it for the rest of the challenges. But now we've done it enough times that I feel like anybody that's kind of figured out the solve probably has a big advantage. So it is a teaching conference. So let's go into helping understand how to solve Haystack 2024. All right. So I'm going to share my screen out. Probably don't want to see me. All right. So first of all, you've downloaded the Haystack 2024 TARD XZ file. All right. So if we list that out, cool. We just, have to extract that. You could, do this through the UI by right-clicking and doing extract here. But I like to show how to do that via command line. So that is how you extract it out. Many of you probably did this via command line and probably started freaking out because it looks a little bit like a zip bomb. But I promise I only made it like 20 megs. So hopefully you had enough space on your system to extract this. But as you can see, there's definitely a lot of file paths that I've built out. Actually, I have a script that generates this every year. So it really doesn't take me any time to actually create this. Um, So we'll wait for that to finish out. You can see my system processes are dying. I'm running this on a woefully underpowered VM, so let the Jeopardy music play. All right, cool. So it's fully extracted. One of the things that you could do at this point, if you are so inclined, is you could run the tree command. If you've not run the tree command before, it's a pretty interesting command because it'll actually show you the structure for the folder paths. It'll also give you some good details about how many folders and how many files exist in that structure. As you can see, it is also eating a lot of resources, but it gives you a nice lay of the land. Again, actually building the script was half the fun for me building these kind of challenges to make it, so there's a good number of entropy or a high level of entropy, but also like an even distribution of folders. So when I created this script, it actually took me quite a while to figure out how to do that right without creating some sort of infinite loop. Anyway, um, so I guess I can kill that. Well, I'll let it run out because I want to get you the count, and then I'll probably close this terminal because then I won't be able to scroll up. Almost there. There we go. All right. So as you can see, we have 333,288 directories and 785 files. So that's pretty stout. All right, I am going to close this because I don't want to have to deal with scrolling through that. I'm going to reopen this and then I'll zoom in this a couple times. My hotkeys are not working in here, so I'm just going to do this a couple times. All right, and we're back. All right, so we've got the Haystack folder. If you open up the Haystack folder, you probably noticed that there's quite a few folders in there without doing a tree. There's also a file at the end, things like that. So, definitely a lot to go through. So what I want to show you is really the secret to solving Haystack much, much quicker. And what you would want to do for that is essentially do a make dir. In this case, we'll call it stuff, right? And then you can do a semicolon here. Basically, if you do any bash scripting, that basically just means separate this command. Let's keep on rolling with another command without having to like hit enter. And what we'll do is we'll just do a find inside of the Haystack folder, and we're going to look for any files. And then we're going to print those file names. And then the zero at the end actually creates a null character at the end of each of the file names. Instead of like when you do like a print command, you would normally have like a slash in for a next line. That's important actually because you want the null character as a separator. In case there's spaces in the file name, it handles that, or any special characters, things like that. And then we're going to do an xargs zero to copy those file names into the folder stuff we just made. So that is what we are going to do. There we go. Cool. All right. So it made the folder stuff. It's still going to be processing all of that. We did. All right, cool. So now that it's done, you should see all the files in one folder. So the reason I didn't want to kind of like show people how to do this initially is because this really kind of ruins a lot of the fun. I've completely eliminated the haystack portion of the challenge now because now it's just a bunch of files in a folder. So so definitely this is something to take note of if you're going to do a haystack challenge in the future. It's a great way to just put all the files in one location. All right. So if we go into CD stuff here and we list it out, you can see all the files in here. So quite a few. If you were thinking to yourself, hey, like, let's see, like, like how many types of files we have of each one. You could do something like, um, let's see, we could do like actually, let me go back a directory. We could do basically like find, um, and then actually, yeah, that'll work. All right, cool. So if we do that, basically what we're saying is we want to look for files. We're going to parse out the file name by the extension. We're going to sort that in a unique way, and then we're going to print the upper, and we're going to count the total number, right? So essentially is what we're doing here. So if I do that, basically it's going to give me a rundown of how many of each file type there is. Actually, that should have been quicker. Oh, I know why. Sorry, that was my bad. So we actually want to do that for stuff, not haystack. There we go. All right, cool. So now you can get a total file count of each one. That's kind of a cool command, right? If you're going to try and figure out how many of each type there is. You can see again, I wrote a script for this, and you can almost kind of tell because there is a lack of entropy in the total number of files. Um, they're almost all the same. It's okay. Anyway, so if we look, there's only one text file. So what I wanted to like prove out here is if you go into like stuff, you could do like a ls and then you can be like star dot text, right? Oh, that's weird. Why isn't that working? Super strange. Why don't we try and cat, star dot text? Like if we were trying to, print them all out. It's so weird, right? Like it doesn't work. So like, why is that happening? So it's something that I wanted to do on purpose, to help teach people that Linux commands actually will parse file names potentially as command line syntax, which could actually be a vulnerability potentially. I'm not sure totally how I would exploit that out, but if you have a terminator like a dash, it actually interprets the that in the name. So, for example, if I go in the stuff folder and I start searching for .text, you'll see there's the text file, right? And you'll see dash at the beginning and dash at the end. It's this dash dot text that's hanging you up. Why it's not getting parsed properly. We could open that up this way, and you'll see it says vimdiff as the hint. Uh, many of you got to this point. You saw vimdiff in the hint and wanted to know what to do with that. Well, so you can still do this all on the command line as well. Just for fun, you actually have to do a dash dash. So, normally if you're going to do help, you would do like dash dash help, and then it would list all your help for LS. In this case, what you'd want to do is dash dash. The second dash actually will terminate. It basically says, don't process any additional, arguments from the command. And then we could do star.text, right? And then it'll list those out for you. Same thing with cat. Cat, you can do the same deal where it's dash dash star.text, and now it will actually show you the contents of the file, which is vimdiff. So cool. So that's something I wanted to teach this year as I ran into that. Actually, as ran into that as I was kind of building it and it unintentionally, and I was like, oh, that's cool. That's a good teaching lesson. So we're gonna do that. I kept it. You could also do something like um, we could do. We could actually start searching through files like you would normally now, right? Because we have them all in a pile. So you could do things like grep, but here's the kicker: grep also parses it. So if you were going to do like a dash IL, which I just means ignore case, the L just means list the file name. You still have to do the dash dash for grep, meaning I'm done parsing any additional commands. You can go ahead and move on with life. So we could grep anything from here, and then you could um, you know pipe it in that way. Oh, sorry, actually do. So if I was looking for anything with HTH 2024, I'm not gonna write it out to a file, but you can actually see that we have 1, 2, 3, 4, 5, 6, 7 files that actually contain the string HTH 2024. So those should be interesting files that you'd want to take a look at. Certainly we could pipe that out to something called files if we wanted to. So if we go back in here, just for the sake of having it as a record, you could do that. So you don't forget where you were. You can do that. You could also do something like maybe you wanted to look for the string flag, right? Oh, bummer. There's nothing there, right? So I didn't have any contents of uh, flag anywhere, but I did put flag in the flag file name, right? So in that case, what we could do is we could do a find and then do dot in name, and then we could look for anything with flag in it, whether it's at the beginning or at the end of the name. So when we do that, we do get one file matching. If you happen to catch this file name, you would have been like, duh. Like I tried to hide it, blend it in there, camouflage it, but so it says con flag, not JK. So I'm not kidding. HTH.PDF. So I tried to match the format just to kind of mask it in there, but what we could do then is move the con flag up a directory. Cool. All right. So now we have the PDF as well. We could try and open that up and see it is password protected. Well, bummer. I don't have the password. Where's the password? So it is indeed with these files. All right. And so the hint vimdiff is going to help you out significantly here. If you've never used vimdiff, this was again something that I wanted to help teach how to do this. Now, of course, it'd be a lot easier if we just had all these files in one folder as well, right? So what I would do then in this case is we could go back one more directory here, and then we could just basically do a find. Um, actually, let's do this. Let's make dir. And let's call it HTH. And oh yeah, they're cool. I already got it. All right. So again, we'll just make the folder HTH, and we're gonna copy. And in this case, I'm using basically a bash syntax. So I'm using a command within a command. So I'm saying copy this variable, whatever runs inside this variable, copy it. So inside the copy command, I'm saying grep and ignore character, the case sensitivity, and list the file names, dash dash. Again, I had to kill the Terminator. Um, all jokes and puns intended with Terminator, by the way, with the theme. And we were looking for HTH 2024, and then we're going to copy it to a directory here. In fact, yeah, so we're grabbing anything from in the stuff folder, which is where we dumped our files. So all files there, and we're going to copy them to the HTH folder we just created, which we haven't created yet. All right, so there we go. Cool. All right, so once that's run inside the HTH folder, you'll see those 7 files. So handy little way of getting just those specific files out of there without having to copy them manually. All right, cool. Let's go ahead and go into that HTH folder. And you can see we have those 7 files here. So this is where vimdiff gets really cool, right? So I can do vimdiff and star on all of these. Now, you can only do so many. I don't know actually what the limit is within vimdiff, but very cool tool to graphically see what's different about files. So when we open that up, it actually makes it incredibly easy to see what I was doing in here. So you'll actually see in red what is different. So you'll see 1, 2, 3, 4, 5, 6, 7, right? So the rest of the string here across the first line is absolutely the same, and everything in the middle is the same. But at the end is different. So that should be your hint that this is the order that these should be in, 2, 3, 4, right? And so that's your hint for how to analyze this file. Now, manually, you could open up each one of these. You could copy the bottom, the last line into a file, and there's only 7 of them, so it would be easy enough to do that, right? Now, there was another challenge in the CTF that I made this year that I was intending on making it impossible to do that because there was way too many files. So I wanted you to get some practice in here on this one. But anyway, that's the idea. All right. So if you've never used vimdiff, the way you exit all is just XA, and then you can get out without modifying any files. If you did happen to hit any weird characters as you were trying to get out of there, you would have modified these files. So hopefully you copied them. Otherwise, you'd have to re-extract the files and get them all over again. So I wasn't trying to be a punk. That's just how vimdiff works. So anyway, cool. Now, if you were to manually do something like a head dash N1, so like basically we wanted to print the first line of all the files, it would give you the file name and the top line, and you could have seen basically that if you just have to do the diff yourself. And certainly you could do tail as well, if you were inclined to do so. Or you could go full ninja. Essentially, what we could do is we could just basically use an awk command to get the contents out. So let's walk through this a little bit because it probably needs some explaining. All right, this is a pretty ninja command. Uh, so let's walk through this one. All right, so awk, it is a powerful processing tool for scanning for patterns, and it reads files line by line. So the FNR is basically the file number record, and we're saying we want the first one in this case, first line of each file. And in this case, we want to print that out. So if you look at it, print, it's actually all within the bracket. So basically, what we're saying is we're printing the file name of that, and then we have a substring command in there. So the 0 in that is actually the current line. The 0 represents the current line, and then the 1 actually represents the the starting position, so the first character, and then the next line is the length of the substring. So we actually just want the first character of each file name is what we're wanting to print. We're going to print all of them for every file, and then we are going to do a sort. All right, so it looks interesting because of the sort having that comma in between. But actually, the when you're looking at the sort, what we're trying to do there is actually take the first field is what that K1 is. And then the in the first field, we want the first character. And then in is actually sorting numerically. So again, the first line in each file was a number. The first character of the first line was a number, and we wanted to sort it in order numerically. So that's how we're doing that. And then we're going to cut field two. Now, normally when you do a cut command, you have to pass a delimiter. In this case, what we're doing is we're using all the middle junk as the delimiter essentially. So we're taking field two, which is the last line. And then we're doing xargs. So anytime you see the brackets with xargs, that's a representation for the file. Basically, we're just trying to read in the file. And let's see. And then we're going to tail, right? So we're taking in the file, um, and then we're going to read the last line and we're going to pipe it out to contents. So that's essentially what we're doing here. Hopefully that all made sense. If it didn't, I'm sure there's some other good help in Linux help. All right, so we just dumped that to contents. So you'll now see there's a contents file. And voila, it has put it in order for us. Again, you could have just opened up each of the 7 files and copied it in one at a time. But I like to make things harder on myself. So that's why I did it that way. Plus, I wanted to do another CTF with lots of stuff in it. So, all right. So if we cat contents, what we'll get is that base 64 string. We could then yeah, contents. Oh, I did that. Base 64, decode it. And what we get is the password is 1984, John Connor. All right, so we can copy that. And then what we can do is we can go back to where the PDF is, paste that in, unlock document, and what? Where's the flag? Like, unbelievable. What's going on here? All right, so in this case, I'm gonna blow this up a little bit. I actually used a PDF builder. It's a command line as well. I used a white background and a white font, so just kind of hit it a little bit. But there is the flag, and I went ahead and did an invisible Terminator, just in honor of both Terminator and also using the null character if you're trying to copy those files out. So it was a little shout out to some Linux command line syntax, but yeah, the flag was HTH and invisible Terminator \0, which is a Terminator. So that is how you solve Haystack. I hope this was kind of a fun way of looking at how to solve something like that, and that you'll be able to apply that in the future for future CTFs and whatever you may run into in the future. That is it. Have fun.